Okay, good morning, good afternoon, or perhaps even good evening to some of you, depending on where you are in the world. Welcome and thank you for joining us for today's penultimate All Things IIoT Day session on activating your industrial data lake for data products, sponsored today by Hitachi Vantara. First off, if you feel like it, please just jump on the chat, tell us who you are, where you are. It's always nice to get a feel for who's joining us. And while you do that, get settled in, grab a coffee, whatever. There are just a few bits of housekeeping that I want to go through. Today's session is going to last just shy of an hour. And first I'll be introducing the topic and the speakers, obviously. And then we'll be looking at some of the key aspects of this industrial data lake topic, as well as showing a demo of Hitachi Vantara's solution in this space in action as well. We'll be getting a lot of valuable insights from our speakers. And of course, we're also going to leave time for some questions from the most important people in the room, which is obviously you, our audience. So please post all your questions in the Q&A tool, not in the chat. It just makes it easier for me to find them, frankly, and I'm all for an easy life, so it will make things much easier if you put them in the Q&A tool. We're also going to be running a quick poll, which we're going to run during the session. There's only 3 questions, so please, when those questions come up during the presentation, then please do answer them, and we'll be able to supply you with the answers that we get later on after the events. So before we get into the main session, I just wanted to give you a quick heads up, as I'm sure most of you are aware. IIoT World runs multiple events throughout the year. And in 2023, there are some great ones coming up. So I just wanted to give you a quick heads up on those. On May the 17th, we've got Manufacturing Day. June the 28th is Energy Day. September 27th, Smart Buildings Day. October 25th, Cybersecurity Day, ICS Cybersecurity Day, sorry. And on December the 7th, Manufacturing Supply Chain Day. You can find all the latest details about those events, speakers, topics, etc., on the IIoT World website, which I'm sure you're all familiar with. A quick shout out to our sponsors. It wouldn't be possible to run any of these great events without our sponsors. And as I mentioned before, the sponsor for today's session is Hitachi Vantara. So thank you very much, guys, for making this possible. And that's it as far as the housekeeping is concerned. So let's get on to the topic itself and introduce the speakers as well. So in this session, we're going to be looking at the challenges that industrial companies face when they're trying to ensure that operations and business data is accurate, complete, up-to-date, and most importantly, actionable, and how industrial data lakes that bring IT and OT data together can help with all of those issues. Specifically, we're going to be looking at how to create a trusted and unified view of data across multiple operating sites and regions using one of these data lakes, how to eliminate data silos, empower optimization decisions, and also enable other operations departments as well. And very importantly, of course, how to control the costs, big data costs, and how to curate and catalog your data and support self-service data flow management. Self-service is a huge topic here, just as it is in lots of other areas of IT, as I'm sure you know. So who's going to be supplying us with all this wonderful insight? Well, it's not mostly going to be me. I'm delighted to say that we're joined by 2 of Hitachi Vantara's leading data lake experts. Firstly, we have Stephen Garbrecht, who's Director of Lumada DataOps and IoT Data Management. He's a value-added and thoughtful leader who helps IT managers to understand the world of operations technology and OT managers to understand the new capabilities that IT can bring to the world of IoT rather. And he really believes that by helping these 2 teams work more closely together, that they can accomplish great things and actually even start transforming the industry. So he's responsible for driving strategy, execution, managing, nurturing talent, delivering growth, forming strategic partnerships, and successfully implementing and overseeing complex projects. So Steve has got a lot on his plate, as I'm sure you'll recognize. He's also extremely experienced in the Internet of Things generally and related topics across pretty much almost any industry you can think of. And so he's going to be explaining what makes industrial data lakes different from other data lakes, the benefits of combining IT and OT data, as well as some of the pitfalls, and providing some customer examples of how industrial data lakes are being leveraged in the field. And I think that's probably going to be one of the most interesting aspects, is to see and hear about what's really going on in the ground in terms of these types of projects. So that's Steve. Next, we have Charles Chatt, who's Director of Lumada Software Solution Engineering at Hitachi Vantara. Charles is the global director leading all aspects of solution engineering for the Lumada DataOps platforms. And this includes helping modernize data management capabilities to deliver tangible business benefits. And let's not forget about that. After all, this is not just an exercise in technology excellence. At the end of the day, we're all looking for business benefits. And his experience spans the full breadth of data ops, analytics, data management, and he's got 18 years, nearly 2 decades of really practical hands-on experience in enterprise architecture, data engineering, and analytics. And for the last 6 years, Charles has been working at Hitachi Vantara as the practice delivery leader. And he's going to be, after Steve has finished talking, he's going to be showing us a short demo, as I mentioned before, of the solution actually in action. So hopefully that's going to be really interesting for you as well. And last but not least, there's me, your moderator for this session. I'm Hamish Mackenzie. I am a former IDC analyst, and I've been running my consulting, advisory, and coaching practice from here in Munich, Germany since 2006. And I specialize in helping B2B SaaS companies, including in this space, but also other parts of the IT world, basically enabling them to grow faster through better positioning and dramatic differentiation against their competitors. So I work with clients in Europe, North America, Asia to help them do that, set strategy, positioning, and it's all about focusing on customer outcomes as far as I'm concerned. And that's, again, what we're going to hear about as well from Steve later on. I'm also the co-founder of Growth Attractors, which is a new venture helping early stage startups get real clarity on their value propositions. And I'm a certified Marshall Goldsmith stakeholder-centered executive coach. If you want to find out more about me, what I do, then please look me up on LinkedIn. I'm pretty sure I'm the only Hamish Mackenzie in Munich on there, so it shouldn't be too difficult to find me. All right, that's enough about me. Quick reminder, if you do have questions, please get them in the Q&A area tool in Zoom, and please start as soon as you like. We're going to be trying to get those during the presentation as well as at the end, just to make it as interactive as we possibly can. So without further ado, I'm going to hand over to Stephen and Charles. Steve, take it away.
Thank you, Hamish. I really appreciate it. And welcome everyone to this presentation on industrial data lakes. As Hamish said, I like to try to bring together the IT and the OT groups to really understand each other a little bit more effectively. So in this presentation, the way we set it up, we hope to give something to the operations people, so people who are actually receivers of analytic applications and the results of IoT data management, but then also the people who actually work with the data, the data engineers, the data scientists, the system integrators, and to let you kind of know about some of the tools that exist out there, some of the things that we see in the projects that we do for data lakes, and really kind of understand it more effectively as part of that. So we hope it's something for everybody that we'll have as part of this presentation. Now, on the next slide here, let's talk a little bit about industrial data lakes. So what's an industrial data lake? I mean, industrial data lakes have been around for a long time, right? We've talked about big data for many years. IoT was going to generate a lot of information. We're going to have to manage this. It was going to be beyond the capabilities of individuals to do a lot of that as part of that. At the same time, there's been an explosion of data in all parts of the business. So talking about customer information, supply chain information, social media, other data feeds that are coming in, all needed to be managed correctly and together as part of that, right? But the industrial portion of it, the operations data, is something special that needs to be accommodated within a data lake, which makes it more of an industrial type of a focus. One of the first aspects of this is being able to store all of this data, but a lot of the data is streaming. It's coming from real-time sensors, from events coming out in the environment, and all that needs to be managed and coordinated from an intake point of view to be able to make sure you're not dropping data and you're leveraging it effectively for the different purposes. Second type is the type of the data. So certainly there's a lot of relational data and general data lakes. There's a lot of documents and things like that, semi-structured like emails. But there's also a lot of unstructured and time series data that comes in with industrial data lakes. And this needs to be accommodated also as part of that. The main purpose of having a data lake is to be able to bridge the gaps between your operations groups and your business groups, to democratize this access and make it more efficient and effectively used by everyone. so that operations people can now have visibility to what's going on outside of their shop environment, for example, or their plant floor around supply chain. And where business teams can now leverage this operations data and use it for, the business purposes that they've been doing all along, that gap that they've had in the understanding that gave them that real-time capability to make decisions more effectively. And it's all about building and running products to do different things, right? We call them data products. It's a new kind of a thing that's produced based upon all the data that we have. For operations optimization, predictive maintenance, cost control, worker productivity for people coming in new into the workforce, to give them advisement on what to do, what advantages they can get, what things to take advantage of at certain times, what optimizations can be done. So that's why an industrial data lake is a little bit different than a traditional data lake. And we're going to talk about how you manage that.
Okay, great. Thanks, Steve. So before we go to get a bit more into the industrial operations data, Lucian, can we maybe have the first poll question? Great, there it is. So what is the biggest data quality problem that you see? Is it about data tag names, out of range sensor readings, mismatched timestamps, or null or intermittent values for streaming data? So if you get your answers in there, that would be really great. I'll just give you a few seconds to decide what you think about that, and then we'll move on. All right, Steve. So why don't you tell us a bit more about why industrial operations data is so different then?
Yeah. So if we can go to the next stage, hopefully those questions were thought-provoking. If we go to the next slide, maybe we can talk about that a little bit more. So why is industrial operations data so different, right? What's different about it versus business data or any other kind of data that you may manage in a data lake? Well, first of all, the construct of locations and disparate data sets and disparate information that's coming in that's, it has a geographical reference. It's coming from a different type of equipment or a different process that's going on. And it's, kind of at the edge of what's going on within the overall business many times, right? Your remote plants, your remote operations that are being undertaken as part of that. All that has to be taken in context with the many different systems, right? It's not just about an ERP system and a CRM system and kind of managing that data together, a financial system. It's also bringing in other information from weather, from security systems, from different manufacturing facilities, power generation facilities. It could be a sports complex and all of the maintenance associated with that. All those many systems that are coming together to be able to feed this data lake and provide that additional value. And then the data types. So we've really taken IoT well beyond the original, approach of it, which was more, how do you manage time series data and make that more of an IT function, to including all kinds of different sensors. It could be audio, could be video, could be different type of sensory conditions that are going on out there. It also could be information coming in from different feeds, external to the environment. So it could be social media, it could be coming in from external government systems, for example. And all of this many types of data needs to be managed together and blended for use within the environment. And that's why industrial operations data is really different in the way you're approaching it. There's so much of a diversity of information that needs to be managed as part of it.
Right. And so we do already have some questions on this coming in, Steve.
Great,
one
let's
is
take some of those. Yeah.
Yeah. So one of them is from Ravi S, and you talked a minute ago about time series data, and he's asking, can you give us an example of unstructured time series data?
So time series data, and I'll ask Charles also to kind of chime in here, is not necessarily considered unstructured, right? Because it can be assembled into a structure with the metadata, the tag name, the value, the units, and things like that. A lot of the unstructured data are things like video and audio or vibration data you may see coming in, right? And the key with that is it needs to be managed and understood for quality, but then also interpreted to pull out events and things like that. So if you got video feeds, is there an anomaly condition that needs to be sensed basically as part of that and pulled out as an event, right? And that gives more structure, more metadata to that those are files that are unstructured as part of that. Structured and unstructured, you can think of structured very much being relational data, things that are assembled in rows and columns, for example, or could be if they needed to be, and the unstructured being more blob data, more things that are not necessarily easily identified, but can be identified, and more data brought out associated with it in the metadata.
Okay. Charles, is there anything else you want to say about that?
Yeah, absolutely. And I've worked with time series databases and unstructured. I've rarely seen kind of the two concepts come together. Very much as Steve had said, the kind of the unstructured, there might be an opportunity to see something maybe semi-structured where there was nested elements in a time series database. But generally speaking, these are, highly optimized for particular data types where they want to have, compression algorithms that are specific to them. And that's what makes those time series databases work just lightning fast. So, at least that's been my experience with it. Be interesting to hear from those in the audience if they've worked with unstructured time series databases.
Okay, thank you for that. And there's another question just about the actual database which is being used for these data lakes. Is there a standard there, or?
Yeah. Typically there are different databases for different purposes. So you may have a Minio database, for example, for unstructured video data. You may have Influx for time series, for example. And there's different open database formats and structures that are typically part of a data lake. So it's not just one individual database. A lot of times it's multiple databases where you have an overlay of the ability to query multiple databases simultaneously through that interface for the data lake.
Absolutely, and I think we all can remember, back when big data was in its infancy, right? Hadoop came out, and that kind of ushered in this era of, the concept of a data lake, and you had things like Hive and HBase and then Impala and some others born out of the open source community. And these were kind of the common, if you would, cylinders or databases that exist. But those have evolved as well. New players have come to the market. Databricks, you've got unstructured players that have come in as well. So it is a wide open field, where now it seems the industry is moving to a point where we focus a lot of the time on open formats, right? We're less concerned with the engine that's running and more concerned of, hey, how do we persist this data so that it becomes accessible to the broadest segment of the market? Because the tools that I'm using today, well, they might evolve, they might be different tools in the future, and I want to make sure that I can work with those and move with technology. Right.
Well said, Charles. Yeah.
Okay, just one more, because before we move on, just because it's something that seems to be coming up from a number of people in relation to the first poll question, and that is that they wanted to have an all of the above option. And that kind of speaks to the fact that in a previous panel, one of the challenges is not having enough data or the right data to get into these data lakes. So is there anything you can say about how to make it easier to get that data in there and make sure it's the right data and usable data? Yeah,
Charles, why don't you start with that one?
Sure, and I think everyone might be aware of the term. I think they've all heard, hey, data lakes turn into data swamps, right? Because the idea is you've got that data as it sits in its raw format and it's unrefined, and you're putting it in there because that has incredible value to folks like data scientists who really want to dig in there. Now, unfortunately, absent the context, understanding what is there, understanding how to use it becomes difficult. And that's where we see kind of this proliferation of, kind of a tool that we'll show a little bit later, our Lumada data catalog. We'll show that catalog and how that would help identify the data that you have in data lake, what is there, provide a means to kind of fingerprint and find out, hey, if I'm looking at just a bunch of numbers in a column, in various columns, hey, can we derive certain meaning from that? I mean, these are all critical questions about, hey, when this thing proliferates, what is there? Is it that I have too much data, or is it that I have data that I'm just unaware of? And those are some interesting problems that I think we now face as these have really taken off.
Exactly. Yep. We'll talk a little bit also about conditioning the data too, to make it more useful. So you like Charles says, you're putting all this data in there and it may not be as useful, or you may think you may not have enough because a lot of it's bad, right? Now, how do you improve it so it can now be used?
Right. Okay. So Steve, why don't you move on to the next section then? I want to make sure that we get through everything.
Great. Thanks, Hamish. So, the big purpose here that we're working toward with these data lakes and IoT in general is to create analytics. And in many cases, AI and these machine learning, these predictors, these prescribers have taken the front seat over IoT, over the value that's provided from the overall solutions that can be created. Where IoT is really the ability to sense, just like you can feel and touch what's going on out there, you can see out in the environment with your body. IoT is collecting this data, giving all the information into AI applications, and then also the ability to reach out, to actually manipulate things with your hands. And IoT can send a message out there to change a set point, for example, or to give a message to somebody to do something, to send an event to another system to do something, right? And AI is really the focus for a lot of this. But in order to have really good AI, everybody knows you got to have good data. You got to have good data that's actually feeding the AI applications, if it's sending out alerts to people, for example. But then also when you're building the application, you got to have the right data. If you don't have the right data sets, you're not going to have an accurate model. You're not going to have an accurate application. So, the problem here is that 90% of this data many times is dark. It's dark in the sense of that it's not used for, not good for purpose. It's unclean. It's not trusted. It's not standardized. Not put into a format that's really useful for people to leverage as part of that. It may be unknown, right? The tag that you have in your historian at your one of the sites in Georgia, for example, the operations team, the engineering team at the site may know very well what that tag is. But I'll tell you what, the people in the supply chain area, in personnel and things like that, maybe they're going to leverage that operations information. They need to know what that means too. So that metadata associated with it to give knowledge to what it is makes it not be dark anymore. And then the quality associated with it is also very important.
Right, and that goes back to what I think Charles was saying before about context, right? Yeah, extremely important. Lucian, do you want to bring up the second poll question, please, right now? So, do you feel your data management and IT team has all the tools and experience they need? Yes, no, or not sure? So, I'll just give you 20, 30 seconds to give your opinion on that one.
Yep. So we're starting to come down to some of the the brass tacks here of really what some of the problems are. And it can be hard. It can really be hard to manage this data, especially if you don't have a lot of the newer experience and the newer capabilities to do it effectively.
Maybe I can also just squeeze one question in here because I think it's a good time to ask this one. It goes back to what we were talking about. Okay, we've got this data lake. We're leveraging multiple databases, but how do you make sure that data gets synced? Across all those databases within the data lake with regard to timestamps.
Oh yeah, Charles, I have something to add there, but maybe you want to talk about it first.
Yeah, I'll say this. I think the timestamps is a very interesting problem. I think for those who might be in the audience who've gone through kind of more of a traditional computer science, you recognize that right away, this is one of those kind of, distributed computing fallacies, right? That there's one clock, right? And that clock is correct, right? This is always a challenge, because if you've got drift one way or the other, as you start to bring those things together, it is always a challenge to be able to kind of create that linear time frame and understand, hey, in which order did these come in, especially when you're aggregating multiple systems together. Yeah, it's always a challenge.
Yeah.
Steve, you said you've got some insight.
It's also really a holistic approach to timestamp synchronization. You can certainly work on it at the source, right? So, there's a lot better ability today than there was 20 years ago to synchronize clocks across computers and computer networks. So, the IT teams and the OT teams try to get together to make sure that works. Daylight savings time, that seems to be something that's always always the last thing to get built into an application, right? That people, we missed that, right? The time changes everywhere. We developed the application in Arizona where they don't have a time series change or a time change. So the source is important, but then also, there are techniques that can be applied to the data after the fact to, correlate it and rationalize those timestamps. You can do retrievals from historians and try to pull it back in all one format. That'll give you at least, from that one historian, a common time reference that it will interpolate data as part of that. You can do further interpolation in the data lake itself when you're setting up data sets for different purposes. So, you try to make it as clean as you can at the source and clean it at the source if you can. And then you can do some things too at the, in the overall repository to make things more accurate too.
Yeah, and then always got to remember that how time zones play into that as well. I know here, at least in the States, the way things have moved around, it's changed over time. And if you're looking, I work a lot in the data and analytics, where we're looking at historical data and trends and making some of those assumptions, especially with reference to time and where that time was recorded, can lead to certain challenges. So yeah, this is kind of one of the problems in computer science that is, difficult to get your arms around.
Okay, great. So Steve, I think we need to move on now. I'm going to let you run through up until to the customer examples, okay? Because I want to make sure we get time for the demo. And it's great that it's so interactive here and asking people's questions, but yeah, we just need to keep an eye on the time.
Great, thanks, Hamish. Appreciate that. So far, there's been lots of optimization that's being done across the organizations, right? Whether you're any kind of industrial organization, whether you're a manufacturer, you're a facility manager, you're an electrical utility, and the optimization has taken place in kind of silos, right? So operations teams have optimized how plants are run. They have advanced optimizers that will do, cost control, optimize for certain parameters to take advantage of opportunities. For flow, for energy, for different purposes and things like that. And they've done a really good job in themselves. Business systems have also been doing lots and lots of work. They have robotic process automation they put in place, workflow. They have different analysis packages and business reporting that's gone on to help to optimize how operations are going as part of that. But that's not enough. Today, you really need to merge together all of your company and your capabilities to really be effective and be competitive and be a leader in the marketplace as part of that. And if you don't, you're gonna fall behind and things won't go that well for you in the long run here. So marrying together this IT and this OT data, merging it together, being able to leverage it in concert is really what helps to do this. It gives you additional automation capability. So now I can, like I said, on a shop floor worker who's assembling something, I can see a view and get alerts as far as when my parts are going to come in to complete that assembly. When I'm out there in the operations area, and I'm providing abilities to service my customers in a call center, for example, I can now have a broader understanding of customer or an operations 360, where I see their billing information, I see location information of what's going on with them right now, their status. I see what the crews are doing and what's being dispatched as part of that, and I can have a better ability to deliver that information to my customer as part of that, right? You can also create new digital products, right? So say you're an expert in chemicals, or you're an expert in electrical power. Your company expertise is in how to run facilities for sports events, right? I can create an application to serve the community as a digital product and make this available as a new revenue stream for my company by doing this. And it takes that business data and operations data to come together, and also a lot of third-party information too coming in. Providing better sourcing agility and demand sensing. So now I can really produce my stock to exactly what my demand is trending toward out there in the marketplace. I can predict market activities. So even taking into account what's going on today, which is very important in inflation, in demand and supply capabilities, to predict what's going to happen in the market, so I can have a better ability to meet my needs and to retain costs and be efficient in the marketplace. And it's all about reducing risk, right? If I can actually understand things more thoroughly, if I can predict and prescribe to people what to do, I can start to institutionalize what I'm doing as a company and really take advantage of all these opportunities by merging together IT and OT information effectively. So in the next slide, let's talk a little bit about what it takes to do this. And a lot of times in the market, we talk about pipelines, being able to orchestrate data from source to analytic and everything in between. And really what's required for this is to fully integrate and be able to integrate and handle your business data and your IT data as efficiently as you do your OT data, your sensor data, your information from your shop floor, and bring that together, be able to onboard it, right? And once you've onboarded it, be able to work with it, right? Forward it to different databases, set up data sets and store them in a certain context, be able to coordinate this activities between edge and cloud. Because in many cases, I can't store everything in the cloud. I can't store everything on the edge. I want to mix, I want a coordination of those two activities as I tier data for use across the organization. And then we talked about, I don't have enough of the right data to do these things, right? Well, first of all, you have to figure out what you have. So being able to classify, discover it, clean it for purposes, right? We're dropping this data in the data lake, but it doesn't mean it has to remain that way. It can now be cleaned and curated for certain purposes. And then being able to further work with that information data and turn it into information. So being able to assemble the data sets that are used for training, being able to set up databases and make that self-service for people to pull information automatically. They don't have to go to the IT team to get something if they need a data set, to rationalize it and standardize it so we all have the same terminology, the same glossary of terms that we're using within the organization, and everybody's able to really leverage it more effectively as part of that. That's the orchestration from a data operations point of view that needs to happen. And we talk about DataOps as a new field of capability to help do that. In the next slide, let's talk a little bit about the data lake solution that we have from Hitachi. So, we don't sell data lakes. So it isn't like a thing that a part number you would buy. Typically a data lake is something that you've already started as an organization, and we'll get involved with companies to help pull in the operations data as part of that, and help to curate it more effectively as part of that. Or we'll work with you to create a data lake from scratch that includes all of your IT and your OT data for different purposes, right? And to take these these dark data puddles, if you will, out there in your environment that are a combination of your operations data from MES systems, APMs, SCADA systems, historians, bring that together into a landing zone and integrate it and cleanse it and standardize it, document it and catalog it for use and contextualize it and let you work with the data more effectively, right? So Charles will talk a little bit about some of the problems that data scientists and data engineers have, and engineers in general, in organizing and governing this data as part of that, and making it useful for everybody to see and use as part of that. So a logical representation of all your data sets that can easily be used across your organization for different purposes. That's what we help to do. And we have the tools that will meet you at what stage you're in your life cycle for that. And we have services too that also can help with this.
Okay, perfect. Lucien, do you want to bring up the last poll question, please? There we go. So if we had access to an ideal set of IT and OT data, my organization would build revenue generating data products, as Steve was just talking about, internal optimization, analytic apps, or improve the self-service environment. So those are your three options. I can tell you just from the previous question, only 10% of people said that they thought they had all the tools and resources they needed. So there's definitely a lot of room for improvement there. All right, so Steve, can I ask you to be kind of quite brief on the customer side? I know it's
Yep.
a shame,
Yep.
but we need to leave time for Charles, and it would be great to just do one or two more questions quite at the end, just right at the end.
Great, glad to, Hamish. So let's go quickly through a couple of examples here, and I'll
Yeah.
be real succinct with it. First of all, a case study with a global energy customer. Now, data management, as it applies to operations, is starting to be a lot like what business requirements were in the past, right? The data governance for compliance is important, right? You could have data that's very proprietary in nature that needs to be managed. You have customer information, for example. In this case, this is a global utility who has literally billions of records of information that they need to manage and curate and make sure that they're abstracting the privacy data away from the data sets when they're using it, and to guarantee that's happening, because they're going to get massive fines if they don't keep an eye on this. So we were able to actually cut down 24% of the reduction of effort it took to do this in creating the data and making sure that it was compliant, and it could be proven very easily to a regulatory agency if they needed to do that. So that's an example of one utility. Let's take another example of a utility, but this could also be a manufacturing organization too. In the next slide, talking about a large energy utility where they've gone and they've done their digitization, right? They put in smart meters, smart infrastructure in place. Now they want to leverage this information, and they want to pull together with other data sets to provide ability for their call center people to give better insights to people, as far as what's going on when they get a call as part of that, right? And even be able to be proactive and give them information ahead of time so that the customer experience is so much better. I live in Texas. We recently had a big ice storm. Power was knocked out everywhere because of tree limbs falling. The biggest problem was the customers weren't getting updated on when their power was going to come back on, and they couldn't make any plans. Do I have to go to a hotel? Do I have to do this? If there was just a way to automatically give them that information by combining all of this IT and OT data together that I have and automatically send that to them, there would be such better, reputation from a utility point of view for companies like that. I know utilities all around the world are dealing with those kind of problems right now. So those are a couple of examples of how you marry together IT and OT data and use a data lake environment to help facilitate that. Now I'll turn it over to you, Hamish, and Charles for the demonstration.
Yeah, perfect. Thank you very much, Steve. All right, Charles. So yeah, are you ready to go with your demo?
Yeah, why don't you get the question in? I'll get queued up and ready to go, and we'll share as soon as, yeah.
Okay, so I'll just ask one quick question from Andrew Miller. Apart from storing the raw data values, one of the most challenging things is the ability to add context and relations to the raw data. Is this possible with data lake technology?
Charles, you want to take that?
Sure. Is it possible to add context to the data that's sitting inside the data?
Yeah. So context, relations, like things like geographic location, telemetry, machine hierarchy. Can you do that with this solution?
Yeah, and we'll show one of those solutions here shortly. In terms of the data catalog that helps provide that contextual information for you. Okay. Because absolutely, this is something that it is a challenge, especially as you get into hierarchies and where things sit within the geography or how these relate together. But it all comes back to metadata, right? Is that not only is there great value inside of in the data itself, but in what is describing that data. And that's why data catalog and products like this, that metadata is such a rich treasure trove to be able to acquire that, curate that, and then have users leverage that.
Perfect. All right, so let's get started with the demo.
All right, so I'm going to go quickly, but just a couple of demos here. So let me start off and just kind of level set. What I'm going to show you here is part of our Pentaho platform. For those who've maybe worked in the data integration and analytics side, this is the same open source, open architecture tool released well over 15 years ago, right? So this is, battle tested, rock solid tool that helps you not only acquire data, but blend it, work with data lakes, work with data warehouses. And I'm going to show you kind of a couple of uses that are specific here to IoT to start with, okay? So what I've got here is, some the folks who've worked with IoT, I'm sure they're familiar with MQTT and deploying in those sorts of environments. And there's other protocols that come in place. So in this case, I'm looking at just kind of simulate, hey, how would we maybe take this, which I know is in an IDE here, on my desktop, but that same transformation that I have here can also be bundled up without the baggage of this UI. And what we would do there is kind of ship that small runtime along with this, and then we could deploy that near the technology. And in this case, what I have moving from left to right is kind of talking about, hey, how would we capture certain metrics, near the source? And in this case, I'm simply reading, although from my own computer here, it could be from OPC UA, it could be collecting it from MQTT, it could be connecting to a whole host of protocols and sources. So in this tool on the left, and I won't speak about it too much, but there is well over 200 different connectors and steps that ship within our product today that allow you to connect to anything from streaming providers to both consume and produce them, to databases, data warehouse steps, big data, kind of runs the gamut here, okay? So a lot of capabilities and a lot of flexibilities, because what we recognize is, hey, those piles of, Python scripts might not be the best way to work with a business analyst or a data scientist, right? So from the left to right, kind of the standard, hey, let's capture it from the source. And in this case, I'm simply just capturing some system information. So rather than running on my computer, let's assume that I deployed this on a device somewhere else, okay? And from there, we can do some light transformations, format some data types, calculate some values, convert that to JSON, right? And then ultimately going into kind of an MQTT producer, right? So where we're able to kind of specify here various topics, our quality of service, full security, and various options that control it. And as this is running here kind of in the background, you can see where kind of the logs are going out and we're kind of producing this today. But this entire experience here is something that you could put in front of an analyst and that they would easily understand, and that you could work with those flows in a visual way, okay? In addition, as I'm working on my desktop, we can also bundle this to run this in the cloud, in the IT, in the OT environment. So has an incredibly small footprint and can be centrally managed, all right?
Mm-hmm.
So this one's kind of your standard, hey, how do I maybe acquire from some sensors and maybe produce into some of those IoT protocols, all right? And then of course, logging. And then we'll take kind of the flip side and kind of more pertinent to what we're talking about over here. So in this one, I've got the MQTT consumer over here. And this one is going to, hang on, give me one moment. And this one's going to grab off that topic that we published there previously. Okay. And it's going to grab the flows from there. It's going to log, kind of extract and transform some of those JSON fields. And then it's going to decide to take that stream and output it into a number of different formats. Okay. And the formats that I've chosen here, these formats are more related to what you would see inside of a data lake, right? We're all familiar with a CSV or a JSON file or XML. These are kind of the tried and true formats that are out there, right? Well, we also augment that with the newer sets of open formats that are being used today. So some of those formats, what they look like is Parquet, ORC, or Avro. And these come into play because one of the things that Steve had spoken about was exactly how much volume, how easy it is to take in a large volume of data. We've worked with customers who I want to read at and store at, 5,000 hertz. Well, there's a cost to that. Okay. Now, some of these formats like Parquet, these are compressible. They're not only compressible, but if you're in an environment like a big data environment that allows parallel processing, it can also be split, which means now I can scale out process across many machines. Okay. And then because it's columnar, very much similar to how a time series database works, you get basically a row identifier, you get the specific data type, and those can be then highly compressed. And we see Parquet as being kind of that winning format that companies are continuing to kind of standardized on. The other one is ORC. So in this one, all of these steps are fully interchangeable. I can take the data stream that I have, and I can, in this case, copy it so that I can go to multiple sources. And then I can spread that around, or I can even load balance that. All right. So in addition to Parquet, we've got an ORC format, and we've got the Avro format. ORC is more of a row and columnar, where it becomes natively splittable, and it's compressible, and it does something called predicate pushdown, which is if I have a certain type of query engine that's running against it, I can push the processing closer to where those files exist, right? And then Avro, another format out there, these are more row-based. So you can imagine if you're pulling in, say, 1,000 tags, right? What that might look like in a row. The columnars kind of look at, a row index and the value separately. In Avro, it looks at it as one large collection. Now that too is natively splittable, and it also allows kind of schema evolution, meaning I can decide later on to change what is in there, and my calling applications would know how to use that. All right. So these newer formats here on the bottom, these are kind of where we see companies going, is using kind of these newer formats. I mean, everyone loves their CSV. I can open it up in Excel, or JSON, but some of these, if you're processing large volumes of data, that becomes a little bit of a problem. The idea being, I want to put that data out in my data lake in a format that is accessible by the largest number of tools. Okay. All right. And with that, in addition to kind of these file formats, the other aspect here is that, not only do we do that, but there's some additional ones, right? So you've got the traditional document stores, all right? We've got MongoDB, Cassandra, a whole host of different data stores that we can connect to. All right. In addition to that, traditional databases that we've always worked with for both transactional, need to just insert a small amount of data. And then I've got the bulk loaders. I've got MySQL down here, but there's steps in here that support Oracle, SQL Server, the common flavors that most folks are using out there. So this is just kind of two examples of not only how to produce it, but then again, hey, here's me picking it up from the MQTT consumer and then spreading it out into whichever format or whichever database engine I might be using. All right. So this is just kind of a short example of kind of two use cases to produce. And then once you've produced or you've put that in a native IoT type protocol, hey, how you can read from that and then use that to fill your data lake in a more contemporary format. Okay. So this is one piece of the offering that Steve spoke about when he talked about that orchestrated pipeline, right? How do you onboard this data into the data lake? The other question, the other pain point I think everyone's kind of raised is, hey, how do I find the context, right? So I'll quickly do, I'll pivot here and just kind of show, here is the, here's our solution. It's the Lumada data catalog. And you can think of this like a large metadata engine, right? It's going to collect metadata from your data estate. So this will collect it from the data lake. So if you've got, if you've got, say, Hadoop running HDFS, or you've got object stores that you connect with Minio, S3, things of that nature, these can connect to it and profile it. All right. And I'll show you here kind of on the left. We'll take a micro view and then we'll back out a little bit. Imagine what you might be able to do if you had at a particular level, automatically being generated from you key metrics from the data assets that are in your data lake, right? Not only that, a rating system, a way to define specific business terms, what fields are there, not only seeing the fields, but then getting a profile and understanding what are the patterns that sit behind that data, and then about the ability to curate it and add some additional descriptions to it. To me, this is that missing piece that solves that day one problem. Coming onto a new team or a new product, and the first thing I need to do is exploratory data analysis. Imagine the power of having this in front of you at your fingertips to know the shape of that data. Okay, this is truly a time saver. Okay. In addition to that, you've got kind of your Amazon-like search, where you can put in various terms and find data sets that may be applicable across the organization. These are not only within the data lake, but we've got traditional data sources in there. So your relational databases, we've even included unstructured data in the newest release. So this just kind of gives everyone kind of a flavor as to what is out there, and would certainly love the opportunity to meet with you and go through kind of a more enriched demonstration. But I'll turn it back over because I do see that we're running quite short on time.
Yeah. Perfect.
Hamish and Charles, just a quick comment here. What we showed on the first set of demonstrations from Charles was really we call a Swiss Army knife of sorts. Pentaho can do all kinds of different calisthenics with the data, from storing it and conditioning it and integrating it. And all this data that comes into the data lake can be used to build applications and reports. But all of those data sets and those data feeds that we're seeing in that easy drag and drop environment for pulling in information and conditioning it lives on to feed the analytics in real time. right? So you're guaranteed that you have a quality data stream that is transformed as part of that. And then to be able to organize that information, understand it, inject the metadata using the data catalog, and understand it more efficiently, just makes it so much more useful, for everybody in the organization to leverage all of this data from operations.
Absolutely. And we're using that data lake as that single point, almost like that interface. And from there, you would then use a tool similar to this, where you're, using these streams, pulling it together to blend that information to create subsequent data sets for others to use, leverage, enrich, and allow your data scientists or your ML engineers, to focus on, those aspects and not worry as much about the data engineering or some of the business analytics tasks that you typically see sprinkled in with, whether it's R code or Python.
And it's actually, Steve, it's perfect that you just mentioned real time there, because we had a question from Indira asking both of you, are you seeing the need for that real time alerts and automation, coming from customers? And how is Hitachi, servicing those needs in relation to real time specifically?
Yeah, and real time means something different to different people. If you talk to people on the shop floor, it's like second data. If we talk about people in supply chain, it could be a daily update on things. Right. So it's really delivering it at the at the rate that people are looking and expecting it for, and a lot of this is very possible. So giving those hourly updates or 15-minute updates on inventory and customer orders to the shop floor, and then on the other side, on the operations side, if you're using planning type information, certainly have a lot of granularity from your operations. What's been produced, what the current inventory levels are. Are there events going on in manufacturing or in production or in the equipment that are now going to cause delays for things going on the business side? Yes, definitely there's a need for alerts for those things. The alerts also need to come with instructions a lot of times too, of what to do, right? So what does this mean? The context of that alert, and also building an analytic that delivers that, where you can give an SMS message or an email to somebody to take action, or whatever system that you're getting alerted through to do something based upon. But it needs to have a little bit of context associated too, which is very possible. Yeah.
Okay, perfect. So Steve, we're nearly out of time. Do you just want to tell people a little bit about what you've got there? How people find out more, get in touch?
So the easy to use tools that were shown by Charles are available for you to download and leverage today. Mm-hmm. We have a free trial and a community edition of Pentaho, which is a very well-known ETL tool, that Swiss Army knife I talked about. You can hit this QR code and download an evaluation copy to try out as part of that, and then contact us just for the professional version that's fully supported that you would use in your enterprise. And also you can discover more information about our data catalog, going through a series of learning modules and trial capabilities with that. And feel free to come to our website for Hitachi Vantara, the Industrial DataOps website. Link is right here. You can learn more about our products. You can learn about how we can also help with solutions. So if you depending on your experience level, if you're very well used to building data lakes and data management, you need some tools to make that possible and more effective, we can help you there. If you're completely starting from scratch, never built a data lake before, don't have the expertise, we can apply consulting and services also to help you with that. Anything in between. So we really think of data as being our lifeblood, and we're here to help you. And we really want to see the industry be successful in using big data in operations.
All right. Thank you very much, Steve. We're going to have to wrap it up now, I'm afraid. For anybody who didn't have their question answered, we have captured all the questions, and we'll make sure that we get answers to you before following the event. So thank you. Sorry, we didn't get time to answer everybody, but we will get back to you with answers to those questions that we didn't get to. So thank you very much to both our speakers, to Steve and Charles. Thank you again to Hitachi Vantara for sponsoring the event, because without without these sponsors, then these events just simply would not happen. Thank you to everybody who attended. I hope you found it valuable. Hope you found it useful. And please do reach out to the guys at Hitachi Vantara if you want to know more, if you want to try out these solutions for yourselves. All right, it's now time to move into the final session of the day, which is MQTT and Sparkplug, delivering plug and play interoperability even for IIoT. Thank you very much again for attending, and have a great rest of your day.